Hello everyone, happy to see you here. Today we have really interesting equations, 3 to the power k equal to k to the power 9. We need to solve this equation for k, so if you have your solution, your answer, your assumption, you can also write it in the comments below and then we will check our answer. Write your notes, write your assumption, write your solution and we will check it. It will be really interesting to check our answers in the end of the video. Okay, so 3 to the power k equal to k to the power 9. So let's start. First of all, let's rewrite this equation in a new line. So 3 to the power k equal to k to the power 9. And what is the best way to solve this question? First of all, I want to split variables and constants. So variables on the left side and our constant on the right side. So that's why, first of all, I want to raise both sides to the power 1 over 9. Okay, so we have 3 to the power k, we raise to the power 1 over 9. And I want to raise our right side, so k to the power 9 raised to the power 1 over 9. And if we look closely on the right side, we can easily cancel this 9 right here and this 9 because we're going to multiply it. Yeah, we have 9 times 1 over 9, so we can easily cancel it according to a property. So we have only k on the right side. And on the right side, when we multiply it, we have 3 to the power k over 9 equal to k. So I hope you understand this first step. Okay, so what we're going to do next? The next thing what we're going to do, we're going to raise both sides to the power 1 over k. Okay, as I said before, we want to split our variables and our constants. So that's why we're going to raise both sides to the power 1 over k. So as a result, what do we have on the left side? 3 to the power k over 9 raised to the power 1 over k. And our right side, k to the power 1 over k. And on the left side, we can easily cancel this k from numerator and from denominator, so we can write it like that. So we have 3 to the power k over 9 times 1 over k equal to k to the power 1 over k. So basically, we can easily cancel this k on our left side. And the final thing, let's write this expression from right side, let's write it on the left side. So basically it changed nothing because right here we have an equal sign. So we have k to the power 1 over k equal to 3 to the power 1 over 9. 1 over 9. So it was our first step. So we just split our equation by variables on the left side and constant on the right side. So what we're gonna do next? The next thing we're gonna do really tricky move. So our right side, so our left side without any changes, so we have k to the power 1 over k, but on the right side I'm going to do very tricky move. So I'm going to write the same expression, 3 to the power 1 over 9, but in the same way I want to raise this to the power 3 and I want to raise this to the power 1 over 3, because basically we can't change our expression, and if we multiply 3 times 1/3, we have the same expression. So basically this is like a tricky move which changed absolutely nothing. But in the same way, we really need to learn and to remember about rule of interchange. Everyone knows about this property. So when we have a to the power x, we had already this property before. So we have, when we had x, a to the power x raised to the power y, we can write it as a to the power x times y. But because this is multiplication, we can write it as a to the power y times x, and in the same way we can write it as a to the power y raised to the power x. And if we look closely, in the beginning we had x and y, so y outside of parentheses, and in the end we have y inside and x outside. So basically we can swap our powers. And let's look closely at this expression. So 1 over 9 and 3 right here. So according to this property, we can easily change this constant by each other, okay, position by each other. So let's do it. So we have k to the power 1 over k equal to, we have 3 to the power 3, we write right here, raised to the power 1 over 9, and raised to the power 3. So we have 1/3, sorry, yeah, we have 1/3. And right now let's simplify our expression. First of all, we write this expression on the left side without any changes. So we have k to the power 1 over k. On the right side, 3 cubed equal to 27. So we have 27 to the power 1 over 9 raised to the power 1/3. And right now on the right side, we can easily simplify our power. We can write it as k to the power 1 over k equal to 27 to the power 1 over 9. So we can write this power right here as 1 over 9 times 1/3. Basically, this is equal to 1 over 27. And this is our final equation. And let's look closely what do we have. We have the same structure. This is the first thing I want to underline, I want to mention, because we have the same structure on both sides. We have 1, and basically we have fraction. Moreover, we have the same k right here, and it's the same k in the power part right here in our denominator. And on the right side, we have absolutely the same structure, the same constant. So only one way for this equation is when k is equal to 27. So k is equal to 27 is a root to this question. And let's check this root real quick. Let's check it. So our proof, let's check it. Maybe this root is wrong. Let's do it. So we have 3 to the power k equal to k to the power 9. Okay, and let's check. So 4k equal to 27. So we have 3 to the power 27. Yeah, we have 3 to the power 27 equal to 27 to the power 9. So first of all, we can leave it like that without any changes, because we have 3 to the power, and basically we can express this 27 as a power of 3. So let's do it. So we have 3 to the power 27 equal to 27 can be written as 3 cubed raised to the power 9, and when we raise this 3 cubed to the power 9, we can write it as 3 to the power 27 on the left side, and on the right side we can write this as 3 to the power 3 times 9, which is equal to 3 to the power 27. So our root is absolutely correct, and it means that our answer is k is equal to 27. But a few thoughts about this question, because of course we can write that our answer is k is equal to 27, so k first equal to 27. But I made a video with x, so 3 to the power x equal to x to the power 9, and I solved this question according to Lambert W function. And it's really great to solve this question according to Lambert W function, because if you solve it according to Lambert W function, you can get the k second equal to 1.15. So according to this method, you can solve this question according to for k first. But according to Lambert W function, we can easily solve it for k second. So it means that these two graphs, 3 to the k to the 9, have like 2 points of intersection. So I really hope you understand it. So according to this method, this is like a special method. I'm not going to say this is like a general method for this type of question, because if you have, for example, k to the power 8, so you can solve this question according to this method. But this is like a special case, so I'm going to show you. I show you this method. So we just split it into parts, and we use this tricky technique. We just use this rule of interchange, and we have our answer. But in general, this is not the best method for this type of question. The best method for this type of question is Lambert W function. So if with Lambert W function, you can solve it for both roots, for k first and for k second. But with this special method, you can solve it for only for k first equal to 27. So k first equal to 27, this is our integer, k second, this is our another root. So this function has 2 points of intersection, first one and the second one. So I really hope you understand my solution. Write your thoughts, write your notes in the comments below. It will be really interesting to read about it. What do you think about this method? This is like a special method. This is not a general method, a tricky method. First of all, we just split it by variables and by our constant, so we have it right here. And secondly, we just do this quick tricky move. So we just use this rule of interchange, and we have the same structure. And as I said before, if you have, for example, 27 to the power 1 over 26, so this method is not good exactly in this case. This is like a special method, so I hope you understand it. For For other expressions like that, for other equations, my quick recommendation is to use Lambert W function. And I had this video on my YouTube channel, maybe 3 to the x equals to x to the 9, and I solved it according to Lambert W function, or if I'm not mistaken, I solved this question for both methods, for this one, and as a second method, I solved it for Lambert W function. So if you're interested, you can easily find this video on my YouTube channel. It's also really interesting and really great to see another branch, okay? So yeah, it is my solution to this question. I really hope you understand it. Write your thoughts, write to respond in the comments below. Maybe there are a lot of teachers here, a lot of students. So write your way. How do you see a solution to this question? Maybe there are a lot of teachers. They see a solution from a different angle. So it's also really interesting to see it from your perspective. So thank you everyone for your time. Take care of yourself. Have a great day, and see you in the next videos.